We are in geotrig lesson 6. We're going to call this one day 1. We're going to start off with fractional equations. What this is that hopefully everybody recognizes that I have a fraction plus a fraction equaling a fraction. Now, that is an equation with fractions, so they call it a fractional equation. Guys, there's a couple different ways that we can handle this. The first way that we could handle this, that most of us would be like, yup, we can do it. I don't want to, but could you take 4/7 and subtract it from both sides? Because I got to get x by itself, right? But that means to get 4/7 to the side, I have to subtract, and then I'm going to subtract 5/3 minus 4/7, which means I have to have a common denominator. So I get a common denominator and put it together to get a fraction. Can you guys visualize the fact that when I bring 4/7 over, I'll have a fraction equaling a fraction at some point? And at that point, I could cross multiply, solve for x. But how many of us want to work with fractions?
0.
Yes. Almost nobody wants to work with fractions. And if they say they do, they're probably lying. So we can use what some other teachers are affectionately call it fraction busting. I want to get rid of fractions when I can. I'd rather work with whole numbers, integers, those things that are nice. And so what if I told you, because there's an equal sign, we can make that happen? Wouldn't you want to work with those types of numbers?
Yeah.
I would think so. And it all comes down to the LCD, which we already asked about, which is the least common denominator. Back in lesson, I want to say 5. Was in lesson 5, we talked about the whole idea of complex fractions, and we solved it using the LCD. So we already found how to find the LCD. Remember, the LCD is kind of like that potluck idea, where you bring something to the party, but you can't bring something that's already been brought, but you can bring the extra, right? The things that are above and beyond what's already there. So, rule number 1 when we found that LCD was to make sure that all of your denominators are factored. Well, can you break 7 down anymore? Can you break 3 down anymore? Can you break down an x plus 2 anymore? Technically, no. This is already technically factored, broken down to its smallest pieces. So you go over to the side and you write LCD equals. You guys remember the next rule after you make sure they're all factored or broken apart? People start showing up at the door. The first guy to the party gets to bring what? Anything or everything. So the first guy brings a 7. Is that okay to go to the party? So I put it in. The next guy shows up and wants to bring an x plus 2. Is an x plus 2 a 7? No. So guess what? He can bring the x plus 2. Remember, we're multiplying everything together. And the last guy brings a 3. Is he allowed to bring a 3?
Yes.
So I have 7, x plus 2, and 3, all multiplied together. We can multiply that together to get 21x plus 2. But guess what? I'm not going to. You can write it down. That's fine. Now, here's the thing. On this problem, I am not going to multiply it together. The next problem, I'm going to have it multiplied together. It is a personal preference. I would know that 21 is made up of what two numbers? 7 and 3. So it's not a difficult number to work with. But here we go. How do I use this? So we built the LCD so that I can multiply both sides. Because what you do to one side of an equation, you have to do to the other. And so, way over here, I have 7, x plus 2, and 3. What I do to the left, I'm going to do to the right. Whoops, I don't need that. 7, x plus 2, and 3. Does everybody agree? What I do to one side, I do to the other?
Yes.
Okay. Well, here's the thing. On the left side, what do you see here? you see a set of parentheses with some stuff inside that's separated with pluses and minuses, right? And if you have a number outside, what can you actually do with that number? Distribute it in. So essentially, what you're saying is that because that thing of 7x plus 2 and 3 is on the outside, I would have to eventually multiply it in. And if I multiply it in, who all gets the 7x plus 2 and 3? Everybody gets it, doesn't it? Do you guys see that the 4 gets it and the 3 gets it? So guess what? I'm just going to rewrite it. When multiplying by the LCD, just like, guys, when we had complex fractions, I didn't just multiply it to the top and bottom, because that's what I did. I eventually distribute in. Everybody got the LCD, didn't they? It's like a parting gift, maybe. Everybody gets an LCD. You get an LCD. You get an LCD. You get an LCD. It's Oprah. You guys don't know Oprah, do you? You get a car, and you get a car. And she did that on one of her episodes. She's like, everybody got a car in the audience. That was pretty cool. Anyways, so, why is this important, guys? It's important because this gets distributed across the tops. This one is distributed to the 5 or multiplied to the 5. That means I have a 7 on top and a 7 on the bottom. 7 in the numerator and denominator. They will eventually cancel out. The 3, or not so 3, the x plus 2 and the x plus 2 will cancel out. The 3's will cancel out. Is there anybody left in the denominator? No. So what are you left with? You're left with an x plus 2, a 3, and a 4. Wait, where did I get these? Here's the x plus 2, yes? The 3 didn't go anywhere, and what else is on top? A 4. So everybody see where the x plus 2, 3, and the 4 come from. Plus, who's left here? A 3, a 7, and a 3. So 3 times 7 times 3. And going over here, I got equals. I have a 5, a 7, and an x plus 2. Is everybody with me on realizing where all of these numbers came from? So now that we're here, 3 times 4 is?
Wow.
So I have 12x plus 2's plus 3 times 7 times 3, which is 63, equals 5 times 7? 35 x plus 2. Now, we could, because we have a constant, like 12 and the 35 in front of a group, a binomial, I could expand those by using distributive property, right? I would have to distribute here, go over to 35 and distribute there, correct? Not that big of a deal. Gather up your like terms and solve. But how many people recognize that the way they're standing, and this is the way I left them, I did this on purpose, is that I got 12 x plus 2's over here, and I've got 35 of them over here.
Can't you subtract them?
I'm going to put them together as they are. So what I'm trying to say, though, it's like if you had a box of food and someone else had the identical box of food, you don't need to unpack the box just to give it to the other side or subtract it from each other. Does that kind of make sense? Leave it all intact. So, which one's smaller? 12 of them or 35 of them? So I'm going to move the smaller version, which does simplify things to smaller numbers. These are gone. So 63 equals, what's 35 of something minus 12 of something?
23 of something?
23 of something, and those somethings happen to be x plus 2's. Now, guess what? Again, you have choices. I could distribute the 23 and solve. Most of us probably would do that. The other option is, wait a minute, 23 is out front. Can't I get rid of the 23 that's multiplied to this group by just dividing by 23 both sides?
Yeah.
Now, guess what? I'm not going to actually do that. I will take the longer route. Now, the reason is 63 divisible by 23 nicely? So therefore, let's just distribute. If it ended up being nice, I would have definitely done it. 23x plus 46. I'm going to subtract 46. 23x equals what number? 17. Definitely not a nice number, is it? So x equals 17 out of 23. Leave it as 17 over 23. Do not put it as a decimal unless it asks. That's not a nice number. Now, how do I know if I'm right? Because that kind of came up, right? How do I know if I did these things right?
Put it back in.
You plug it back in and check it. Put it in for x. Make sure the left-hand side equals the right-hand side. Moving on, we can apply the same skill, but not with one equation, but two, so that we can solve the system. We have solved systems before. Last year, the year before, this year as well. Now, you have to fix them. I want to fraction bust these first before we put them together. What are the denominators in the first equation? Because we have 3/7 x plus 2/5 y equals 11. A 7, a 5, and a 1. What is the LCD between 7, 5, and 1?
35.
It's 35. So guess what? If I take that and multiply the whole entire equation by 35, the denominators will be gone. And so let's do that. What's 35 times 3/7? Stop. Let's think of this. What's 35 divided by 7?
5.
And 5 times 3 is?
15.
I did not need to use a calculator. What's 35 divided by 5? And 7 times 2 is? So it's 14y. And equals, don't forget to go all the way across. What's 35 times 11? Guys, I went over this last hour. This is the reason why students struggle with math. They don't start to see connections to things that they have done in the past, and so that you can come up with numbers quicker. Is this 11 times 35? You guys can see this?
385.
Doesn't that mean the same thing as
35 times 10 plus 1.
10 plus 1, which is 11? And if I use distributive property, 3 times 10 is 350. 35 times 1 is,
35.
which is 385. It makes it go that much quicker, and at your age, you guys assume that if I can get it done quicker, it must be easier. Okay. Next equation, guys. That's an interesting one. Because it's not fractions, is it?
No.
It's decimals. And if I want to get rid of a decimal, I'm going to have to use the fact that there's a special number, guys, that when I multiply or divide by it, it moves a decimal to the left or right. It's 10. If I multiply by 10, decimal points go to the right. If I divide by 10, they go to the left. Now, if I multiply by 10, it moves it once. If I multiply by 10 squared, or 100, it moves it twice. 1,000 moves it 3 times. How many decimal places are the most used in our problem? It's 2. I got 0.03 and negative 0.37. I need to move it twice. The 0.2 will go along for the ride then. So I can multiply this equation by 100. And if I multiply 0.03 by 100, I end up with 3x. Minus, because that's 2 decimal places, which is 20y. 2 decimal places places it at negative 37. Your choice, ladies and gentlemen, if you guys want to solve this with substitution or elimination. There's one particular method that I would use. I would use elimination. Now, I choose not to use substitution. It would work. But to use substitution, are all numbers divisible by 15 here?
No.
Are they all divisible by 14?
No.
No. How about, are they all here divisible by 3?
No.
Or 20? No. So therefore, I don't want to use substitution if I'm not forced to. So if I was going to use elimination, which is my preferred method here, which equation, or say what variable are you guys going to get rid of first? The x's. So you're going to multiply which equation by how much? You're going to multiply the bottom one by 5. Not 5, but yes, negative 5. Why negative 5 instead of 5?
So you can cancel it out.
You could cancel it both ways, actually.
You're looking to cancel out the 15 for the x.
I understand that. Both methods, if I multiply by 5 or negative 5, will get me to the same solution. One of those methods I have to subtract, and one I have to add. Which one would you rather do? I'd rather add. And to add, they have to have the same number, coefficient, but opposite in signs. So that's why I'm going to multiply by negative 5, so that I get a negative 15. Distribute through it, it's a negative 15x. Negative negative makes a positive 100y. And again, a negative negative makes a, and it ends up being 185. Using the same method from before, but the distributive property. It works. It's really cool. I'd use 40 minus 3 instead. Goes 200 minus 15. 185. Now, I can add them up. Gone. 114 equals a 0, carry the 1, 7, carry the 1, 570. Divide both sides by 114. So y equals, now let's think of this. This is interesting. How many times does 100 go into 500? 5 times. So the question really comes down to, it would be turn out to be a 5, would be awesome, if 70 divided by 14 is 5. Is that true?
Oh, yeah.
So the answer is 5.
Oh, yeah.
Are you done with the problem?
No.
No, because you still need what?
X.
You need x. Any other time we were doing this, I would always tell you, go back to the original problems. This time, do not do that. I am not going to take 5 and multiply it by 2/5 and then work with fractions. I'm not going to take 5 and multiply it by 0.2 and work with decimals. You fixed the problem of those here at this level. Choose which equation you want to use here. Which one? I prefer the bottom here because 3, negative 20, and negative 37 are smaller than 15, 14, and 385. It does not matter. So 15x, nope, sorry, wrong equation, reading it wrong. 3x minus 20 times 5 equals negative 37. Negative 20 times 5. I'm going to add 100. So 3x equals 63. Divide by 3x equals. So our point is 21, 5. It is a system. Write the point. Lesson 6, page 52. Day 1 is 4 through 7, 10, 13 through 20. 13 through 20 is like our quiz from lesson 5. You may want to start there. And then 4 through 7 and 10 highlight what we just did. Have a great day.